An outline of part of the periodic table is shown. The letters are not the usual symbols. Okay. Which elements are in the S block of the periodic table? You know, S block contains how many groups? Group 1 and group 2. S block means that group 1 and group 2. So I'm talking about this one. This is S block. This is your P block. This is your D block. Okay. So they are asking that which elements are in the S block of the periodic table. So of course we have R and U. So that's why option A would be correct. Option A would be correct. Okay. And then they are saying in part B, which element has four occupied quantum shells with six electrons in the outermost shell? You know, six electron means that it's going to give you the group number. The group number is equal to the number of valence electrons. Okay, so six electron means it would be in group six. Okay, it would be in group six of the periodic table. And they are saying has four occupied quantum shells, which means that it's going to give you the period number. So four means that it would be a period number. So can you tell me what should be the answer? So you have V, X, Y, and Z. What do you think?
Why?
Yes, exactly. You know why? What's the why? Why is the answer? Because
Group
it's
6
in
and
fourth
group 4.
period. Exactly, and it's in group six. So this is group six, and this is fourth period. So that's why Y is your correct option. Okay, so you need to know like what's the group number is going to show and also the period number. So group number means valence electrons, outer electrons, and the period number means that the total number of shells. Now see this, in which pair do the ions have the same electronic configuration? Same electronic configuration means that they would be having the same number of electrons. They would be having the same number of electrons. So what do you think, which is supposed to have the same number of electrons? This is the periodic table. So they have given R plus and T2 minus, R plus and T2 minus, and they are saying T2 minus, T2 minus, and Y2 minus, and they are saying U2 plus and T2 minus. So this is U2 plus and U2 plus and W minus. Yep. So same number of electrons. Yeah. Of course, the periodic table would be given to you. Okay, then you have to identify the elements. Then of course you would be having the proton numbers. So you can just see the number of electrons, and then you can get an idea like which two elements are going to have the same number of electrons. So I can say they would be having the same electronic configuration. So if you can see uh, U plus 2, I think so it's calcium. Calcium is 20. It's having plus 2 charge, means that it has 18 electrons. Okay, it has 18 electrons. And if you can check T, it's group 6. You know what it should be? What is T? Calcium. Then
Uh,
what is T2 minus?
is it
Just look at
oxygen?
the periodic table.
1, 2, 6, group 6. I guess oxygen.
So, so if this is an oxygen, so what's the proton number for oxygen? Of course, it's
Oxygen
8.
16. Oh, sorry.
Yeah. So can you see the periodic table and then tell me what is this?
Yeah, it's oxygen and has an 18, see 8 electrons. So 8 with 2 plus charge, so 6
Minus 2.
minus 2, so 4.
Uh, It's sodium, then magnesium, then aluminium, then silicon, then phosphorus, then sulfur. It's sulfur. It's not oxygen. It's sulfur. It's sulfur. Sulfur is 16. Sulfur is 16 and it has -2 charge, means that +2, like the total electrons are again 18. So if the number of electrons are same, it's sulfur. Sulfur is -2. -2 means that the proton number is 16, means that it has total 16 electrons. Okay, so 16 plus 2 is equal to 18. So I can say the answer is C because U2 plus and T2 minus, they both have the same number of electrons. So of course, when it has the same number of electrons, so the electronic configuration would be the same. So that's why C is your correct option. Simple. Now, this question is about phosphorus and sulfur. Which species contains 15 protons, 16 neutrons, and 18 electrons? So, 15 protons. Proton number is the identification of the particular element. Now, you will go to the periodic table and you can see what is 15. Of course, it's phosphorus. It's not sulfur. Sulfur is 16. It may be A, it may be B. It may be A, it may be B. Okay. And then you have to decide it has 18 electrons,
So
means
since the
that
charge is
18
3 minus, it's a
exactly 3 minus because it has gained 3 more electrons. So the total electrons are 18 right now. So A is your correct option. Then which is the electronic configuration of nitrogen? Nitrogen is 7. If you can see the periodic table, nitrogen is 7. 7 means that 1s2, then 2s2, then
option C.
2p3. So
1, 2, 3, 4, 5, 6.
so the
Option D.
answer would be D for
D.
doctor. Exactly, D for doctor. Can you tell me why not it's C?
Because according to the three laws, the arrow should be first arranged in all the boxes.
Yeah, the principle says, the rule says, first of all, you have to fill electrons in a single manner. And after filling electrons in a single manner, then you can start with the double. So you cannot fill electrons directly, like you can say in the same orbitals, I cannot put two electrons. First of all, we have to put single electrons, then we have to double it. So that's why D for doctor is correct. Okay, simple. A sample of neon contains the following isotopes. What is the relative atomic mass of neon to two decimal places? So we have to apply the formula that is equal to isotopic mass multiplied by abundance. Okay, then we have to sum it up. Then we would be getting the final answer. So 20 multiplied by 90.92 plus 21 times 0.26 plus 22 times 8.82 divided by 100, it's gonna give you AR of neon. Can you tell me the answer?
Yeah, wait.
Yes, 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 yes. What's the
So
answer?
20.18.
Exactly. So the answer is C. Okay. Then they are saying data from the mass spectrum of a sample of pure iron is given in the table. Which species is most likely to cause the peak at mass to charge 28? So yeah, what do you think? Mhm. Remember, when you can see the relative height of the peak is the maximum, when the relative peak height is the maximum, you know, so it's the most likely peak in that mass spectrum. We have a lot of like peaks in the mass spectrum. Okay, Like let's suppose if you are going to have, if you are going to have butane, like CH3, CH2, CH2, CH3. This is butane. So it may be that it would give you the peak at 15 because the MR of CH3 is 15 and I think so it's 43. So these are the possible peaks in the mass spectrum, of course. But if you ask which is the most stable peak, so I would say the most stable peak would be the one with the higher relative peak height. So they are asking the same thing in this question. They have given you like multiple peaks like 28, then 54, then 56, then 57, then 58. Which species is most likely to cause the peak at mass to charge like 28? So I would say that mass to charge. You know, what is the mass of this iron? 28. What is the charge divided by 1? What is the charge divided by 1? So it would be equal to 28. It would be equal to, but the peak height is very low. The peak height is very low. So let's check option B. 56 divided by, what's the charge? It's 2. So what's the answer? It would be 28. Okay, let's check C. 28 divided by plus 1, it would be giving you 28. Again you can check the relative peak height. So I would say that this is the final answer because it has a relative peak height that is equal to 100. Okay, so I would say that the answer is B for ball. So
Sir,
whenever you can see this question, so you are supposed to check the relative peak height. If the relative peak height is maximum, so you can say this is the most likely, this would be the correct option. Yes, you are asking something.
no. Something came up. Can I just leave and I'll just be recording? When's the next class?
Sorry, when is the?
Next class. Something came up right now and I have to go.
Okay, okay. I'm recording it. I would be uploading this. Okay, don't
Yeah,
worry.
yeah. Thank you.
Okay. Now, which of these is not a chemical reaction? Cracking, fractional distillation, polymerization, and reforming. Can you tell me which of these is not a chemical reaction? Yes? Of course, cracking is a chemical reaction because in this we can see the new products. We can see the bonds are going to break down. The bonds are going to break down. Fractional distillation. If you remember, if you remember, we had a crude oil. We were separating the mixed, like we were separating the different components on the basis of their boiling points. It's not a chemical reaction. It's only separation. So we can separate the mixtures. We are not going to separate the compounds in fractional distillation because if you remember we used to tell you that like crude oil is a complex mixture of hydrocarbon. It was not a compound, it was a mixture. So this is not a chemical reaction, it's a physical change. We are just going to separate the different mixtures on the basis of their boiling points. Simple. Okay, so B is your correct option. Which of these fuels is obtained from fermented sugar cane? Of course, you must remember, like you must memorize the chemical reactions and their products If you remember, we used to discuss fermentation. In fermentation, we had glucose. Glucose were breaking down in the presence of yeast. That was a biological catalyst. And what was the condition? Anaerobic condition. Anaerobic means that there is no air, there is no oxygen. Anaerobic condition. So glucose were breaking down into ethanol and carbon dioxide. Simple, and that reaction was exothermic. So that's why, in my mind, that was the reaction. So when I saw this question, which of these fuels is obtained from fermented sugar cane? So I got to know that it was ethanol. Okay, so you need to memorize some reactions as well. Okay, first of all, you have to memorize. Then the second step would be the concept. What is the systematic name for this compound? So now you have to decide between cis and trans isomerism. Cis, trans, cis, then trans. Cis means cis. Cis means the Z isomer, and trans means the E isomer. Trans means the opposite. Opposite. Cis means the same side. Cis means the same side. You know, what is this? First of all, you have to decide, of course, what are the conditions? What are the conditions for the cis and trans isomers? Number one, you must have a double bond. Number two, you must have the different groups attached on the double bonded carbon atom. I mean to say that if this is CH3, this is H. If this is H, this is the different group. So these are the conditions. Let's suppose I have this one. I have this one molecule, right? I have this one molecule. You know, it's not gonna give you the cis trans isomer. It's not gonna give you the cis trans isomer. If you ask why, I would say that it has same groups attached to the double bonded carbon. It has same groups attached to the double bonded carbon. So that's why it's not going to give us the cis trans isomerism. So of course, the molecule that they have given to us is going to give us a cis trans isomer. Then we have to decide, is that cis? Is that cis or a trans? So can you tell me, is this cis or trans? Yep. Can anyone tell me? Yes? Any idea? What is, like, is this cis or trans? Hmm? No? Cis? Yeah. No, 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 no. This is trans. This is trans. This is not cis. This is trans. This is carbon. This is carbon. You know, this is what? This is carbon. Opposite side. Opposite side. 180 degree. Opposite side. 180 degree. So of course, this is the trans. So trans means E. Trans means E. Then you have to see the options. It's incorrect. It's incorrect because they are Z. Okay, we have to select the option which is going to have E. So I have decided that A or C may be the correct one options. Then we have to see which is the best one. Which is the best one? Of course, if you remember when we were going when we were giving the names to an organic compound. So what was the rule? We are supposed to give the lowest number to the double bond. Okay, one, two, three, four, five, six. Okay, at the fifth position, we have a methyl group. This is the branch. So 5 methyl. It's 2 methyl. C is wrong. A is your correct option. It's very easy. It's a baby question. It's very easy question. Okay. Yep. A is correct. Good. Okay. Now you can see question number 9. They are saying that ethene reacts with bromine to form 1,2-dibromoethane. For the ethene molecule, what is the type of bond broken and the type of bond fission occurring in this reaction? So of course, if you can see the double bond, if you can see the double bond means that it has sigma and it has a pi bond. It has sigma and it has a pi bond. Okay, so when the addition reaction is going to take place, so means that the pi bond is going to break down. So pi means that it may be A, it may be B. Okay, so we are going to filter the options. So the probability of getting a correct answer is going to increase. So A or B may be correct. Then we have to see, is this heterolytic fission or a homolytic fission? So how can I say what is this? So remember, if you can see the non-polar molecule, listen very carefully. If you have a non-polar molecule, means that H2Cl2 Br2 I2 At2 N2 O2, okay, F2. These are non-polar ones, diatomic molecules. If you are going to break the bond, if you are going to break the covalent bond, so it would be called homolytic fission. You know how? Cl, then Cl. The bond is going to break down in this manner. It's called homolytic fission, even distribution of electron. But if you have HCl, HCl, of course, it's polar one. Chlorine is highly electronegative. So it's going to gain electron. It's going to attract electrons towards itself. It would be partial negative and it would be partial positive. So it's called heterolytic fission. It's called heterolytic fission. So since this is a polar molecule because it has a double bond, okay, because it has a double bond, so of course it would be heterolytic. So A option is correct. Okay, A option is correct. Then they are saying there is 0.05 gram of solute in 1500 gram of a solution. What is the concentration of the solution in parts per million? In parts per million. Yeah, what do you say about that? What is parts per million? You need to know what is parts per million. Can anyone tell me? Can anyone tell me what is parts per million? Yep. Mhm. Going to give you only 1 minute. Yes. Hmm. Any idea? Yep.
Is the answer C?
C. Why? Javeria, how did you do this question?
I use the formula the solvent divided by solute. I mean,
Okay. Solute
into
divided by
multiply by,
solvent, 10
yeah,
raised to the power 6. Okay.
yes,
So 0.045 divided by 1500. What's the answer? Then you did 10 raised to the power 6. What's the answer?
30.
Okay, so C is your correct option. Okay. Then question number 11. What is the concentration in mole per dm cube of a solution containing 7.84 grams of phosphoric acid? H3PO4 in 400 centimeter cube of solution. So they're asking the concentration in moles per decimeter cube, but they have given the mass. So you have to convert the mass into the mole, and then you have to convert the centimeter cube into the decimeter cube. Then you are supposed to divide moles by volume, then you would be getting the concentration in moles per decimeter cube. So first of all, I am going to find out the moles of phosphoric acid, that is equal to 7.84 divided by the molecular mass of H3PO4. Can you tell me the molecular mass of H3PO4?
98.
98. Okay. And what's the answer of mole? Mhm, mhm, mhm.
0.08.
0.08 mole and then divided by 400 into 10 raised to the power minus 3 because I have converted cm cube into the decimeter cube. Then you would be solving it. Then you would be getting the final answer.
0.2.
So 0.
0.2.
2.
0.2. Okay. So means that C is your correct option. Okay. Good. A sample of hydrocarbon with a mass 7.2 gram contains 6 grams of carbon. What is the empirical formula of the hydrocarbon? So it's very easy question. You did in your IGCSE as well. Okay. So uh, so in sometime they are going to give you the percentage of the elements, and sometime they are going to give you the masses of each and every element. So in this question they have given the mass, not a percentage. So hydrocarbon means that hydrocarbon is going to have carbon and hydrogen only. So they have given the mass of carbon. And how can we find out the mass of hydrogen? Of course, I have to subtract the mass of carbon from the total mass of a compound, that is 7.2. So this is carbon, this is hydrogen. Carbon is 6.0. Hydrogen is 7.2 minus 6.0 divided by atomic mass of carbon, that is 12, divided by the atomic mass of hydrogen, that is 1. I would be getting 0.5 mole. And then 1.2 mole. Okay, 1.2 mole. Then I have to find out the simple mole ratio by dividing with the least number, that is 0.5. So I would be getting 1, and 1.2 over 0.5. What's the answer?
2.4.
2.4. Then what am I supposed to do? Mhm.
A would be the answer because we won't be able to round off.
No,
So
we are
we'll
not
take 2.
supposed to round it off. We are not supposed to round it off. We have to make it a whole
Multiply.
number. So
Multiply by
multiply,
5.
exactly.
Oh,
Multiplied
yeah.
by 5. So you would be getting what? You would be
12.
getting what?
1 is to 5 is to 12.
5 is to 12. So means that B is your correct option, right? Okay.
Mhm.
Yep. Which pair of substances contains the same number of moles at room temperature and pressure? Same number of moles, same number of moles, same number of moles. Which pair of substance? So it's one pair, it's another pair. First pair, second pair, first pair, second pair, first pair, second pair. So it's very easy question. So you are supposed to first find out the moles of each and every pair, then you are supposed to compare it. So that would be correct option, which is going to have the same number of moles. So 24 24 is the volume of chlorine, since it's a gas. So you know what I would be applying the formula? Mole is equal to 24 by 24. I would be getting mole. And then 20 grams upon 20. No. 20 grams upon 40, because the atomic mass of calcium is 40. It's 0.5 mole. So they are not having the same number of moles. A is incorrect option. Then same goes with B, same goes with C, same goes with D. Okay. In B for ball, 24 over 24, same mole, 1 mole. Okay. And 14 grams. What's the AR of lithium? It's 7. So it's 2 mole. Again, they are not the same. B is also incorrect. Then you have to check C. 1.2 over 24. 2.7 over 27. Atomic mass of lithium or aluminium is 27. So 1.2 over 24 and 2.7 upon 27. Are they the same number of moles? Yes or no?
No, they're not.
Okay. 100% D is correct, but we have to calculate it. 1.2 divided by 24. 1.2 divided by 24, because the atomic mass of magnesium is 24. So that's why D is your correct option, because they are having the same number of moles. Okay. What are the maximum numbers of electrons in a 2p orbital and in the third quantum shell? So maximum number of electrons in a 2p orbital maximum number of electron orbital. Remember, remember, we have a p subshell. It's going to have maximum 6 electrons, and this p subshell is going to divide into three orbitals, px, py, pz. Each orbital is having 2 electrons. Each orbital is having 2 electrons. So it may be A, it may be B, because they are asking orbital. They're not asking the subshell. Okay, A or B may, because Javeria is saying D for doctor. Javeria, nahi, nahi. It may be A, it may be B, because they are asking about the orbital. Each orbital has a maximum capacity that is equal to 2. Each and every orbital, 2, maximum 2, okay? So, and then maximum number of electrons in the third quantum shell, which is going to be 18, maximum 18, okay? Maximum is 18. So that is the third quantum. If you remember, we used to write that electronic configuration in the previous classes. Let's suppose I'm going to ask to write down the electronic configuration of calcium. Okay, so that would be 2 comma 8. Okay, like let's suppose it's plus 2. So it's 2 comma 8 comma 8, total 18 electrons. And if this would be plus like zero charge, so that would be 2 comma 8 comma 8 comma 2. Okay, so these are the quantum shells. So they are asking maximum number of electrons in the third quantum shell, so that would be 18. Okay, so they are asking about the electronic configuration. Now see this, it's a good question related to chemical bonding. Water reacts with H plus. H2O reacts with H plus to form H3O plus. Identify the bonding within the H3O plus ion. Yep. What is this? Of course, it's not going to have ionic bonding. Exactly. It's not going to have ionic bonding. It's not going to have any metal or any opposite charges. So, so understood that it's going to have a covalent bond, and then we have to decide okay, is that there is a dative bond or not. So water is having two lone pair of electrons. They are going to give the lone pair of electron to this hydrogen, to this H plus. This is the definition of dative bond, that it's a sharing of lone pair of electron, sharing of electron pair, sharing of electron pair by one atom, by the same atom. So means B for ball is correct. So two types of bonds are there. And can you tell me it's ammonium chloride. It's ammonium chloride. How many bonds are present in this ammonium chloride? How many types of bonds are present in this ammonium chloride? It's going to have three bonds: ionic, covalent, dative. Now you are thinking, sir, is there a metal in this compound? I would say no. But remember, ammonium. It's ammonium. It's going to have a positive charge. It's ammonium. It's Cl minus. It's chloride. You know, Ionic bonding means electrostatic force of attraction between the oppositely charged ions. So between this and this, ionic bond is there. Ionic bond is there. And NH4, like NHH, okay, this is going to have a covalent bond, and this is the third one bond, the fourth one bond, that is the dative bond. So that's why I'm saying it has the three types of bond present: dative, covalent, and ionic. It's very important. Okay, now can you tell me the next question? You must memorize the shapes and the bond angles after looking at the lone pair and the bond pair. Javeria is saying it's C. Javeria, you are wrong. It's not C. It's not C. Yep. Remember, in AlCl3, you need to memorize this. Let me tell you this. Let me tell you the notes of chemical bonding. You need to memorize. You need to memorize this one. You need to memorize this one. Yeah, this one. So I'm going to check how many lone pairs and bond pairs are present in AlCl3. So I would say that in AlCl3 we have we have uh, three bond pairs and zero lone pair. And in pH3 you have one lone pair on phosphorus. So one lone pair and three bond pair. Okay, so the geometry of AlCl3 would be planar. It may be C, it may be D, because it's planar, because it's planar. Okay, and then what is the geometry of this one when you have one lone pair? When you have one lone pair and three bond pairs, if you can check this, if you can check this one. Okay, okay, it's pyramid shape, it's pyramid shape. That's why D for doctor is correct because it's pyramidal, it's trigonal planar, it's trigonal planar. Okay, so very easy, very easy. Hmm? Okay, so now do this, which describes the polarity of the carbon chlorine bond and the polarity of the CCl4 molecule. So you know what is this CCl, polarity of CCl, polarity of CCl, it's polar, it's polar. If you ask how can I identify whether the bond is polar or a non-polar, so if you can see the different atoms, if you can see the different elements, carbon chlorine, carbon bromine, carbon fluorine, carbon iodine. So it would be polar. Polar, polar, we have two options, C and D, and then we have to decide about CCl4. That they are asking about molecule. They are not asking about the bond, like the whole molecule. It's tetrahedral. It's tetrahedral. It has the same atoms, Cl, Cl, Cl. Cl, 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 they are going to cancel. They are going to cancel each other in this manner, just like carbon dioxide. Just like carbon dioxide. They are going to cancel the dipoles. They are going to cancel the dipoles. So as a result, carbon dioxide is non-polar. Carbon dioxide is non in the same way, in the same manner. This CCl4 molecule is also the non-polar one because they are going to cancel each other. That's why option D is correct and option C is wrong. It's quite tricky topic. You need to revise this topic. Whether we are going to identify the polar molecule or a non-polar molecule, and what are the factors that after looking at that factors we can decide whether the molecule is a polar and a non-polar. So basically you have two types of concepts in this: polar bond and a polar molecule. There is a difference between these two, polar bond and a polar molecule. When they are asking about the molecule, so means that you have to see overall. You have to see overall. And when they are asking the bond, then you have to see, like, is the bond present between the same atoms or a different atom? Of course, this is the different one. So if there is a different element, so you can say the bond is polar. Like if you have H, H, Cl, Cl, Br, Br, N, N, O, O, F, F, I. So they are non-polar, non-polar. Okay, that's why option D is correct. Okay. What is the empirical formula of the following molecule? It's a baby question, baby. Yes.
Uh,
Mm, First of all, you have to find out the molecular formula, then you have to cancel it out, then you would be getting the empirical formula. So now you have to count the number of atoms in this, how many carbons, how many hydrogens, how many chlorines we have. Okay, so one, okay, so I have one, two, three, four, five, six, seven, eight, C8, three hydrogens, two hydrogens, one, one, two, 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 one, one, no, sorry, two, and then one. How many hydrogens I have? Three plus one plus two, okay, and then two, 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 one. Can you tell me the total answer? Yep.
16.
So
14.
16 and then Cl2. Cl2, I'm gonna cancel it out. I'm gonna cancel it out. I would be getting 2, 2, 2,
Hydrogen,
4, and then 8, then 1. So C4,
hydrogen
oh
is
my
14.
God,
3, 4,
It's 14 hydrogens.
14
sorry, sorry,
hydrogens. Oh my God, okay, 14 hydrogens. So, uh-huh. So means that Cl2. So I think B is your correct option. Am I right? Am I right? C8, C8, H17, oh sorry, 14, H14, and Cl2 divided by 2. C4, CH7, Cl1. So that's why option B is correct. So whenever you're going to do these type of questions, you're supposed to first count the number of atoms, then you're supposed to divide it by the simple one, that is 2, and then you would be getting the empirical formula. Simple. Okay. The graph shows the first ionization energies for the elements with atomic numbers from 3 to 12. Write the equation for the first ionization energy of nitrogen. Include state symbols. Ionization means the loss of
N,
electron. And
N
gas,
gives
it's
out
going to lose
N
one
plus.
electron. Yeah, and N plus gas. Include state samples. It's of 1 mark. So you would be getting the final full 2 marks. State samples, you know why it's going to ask? Because when you are going to write nitrogen liquid or nitrogen solid or nitrogen aqueous, like any sample other than gas, you would not be getting the mark because if you remember the definition of ionization energy at that time, you have learned that the energy which is required to remove an electron from the outer shell of a gaseous atom. You cannot remove electron from the solid, you cannot remove electron from the liquid, you cannot remove electron from the aqueous one. You can only remove electron from the gas. That's why whenever you are going to write the ionization energy equation, so you are supposed to write down the state symbol that should be gas. Simple. Explain the changes in the first ionization energy for the elements with atomic numbers from 3 to 10. 3 to 10. 3 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10. So. Like with atomic number from 3 to 12. So can you tell me what is this?
Yes, the charge increase. The ionization energy increase because the charge increase, more number of protons, so greater attraction between the nucleus and the electron.
Yeah, of course. If you can see, it's a general increase in ionization energy. It's a general increase. Of course, we have some like differences, some anomalous points, if you can see, that are not going to follow this. But overall, it's gonna increase. Overall, it's gonna increase. So, why it's going to increase? You know, it's
Nuclear charge.
across the period. Yeah, it's across the period. Whenever you are going from left to right, the proton number increases, so the nuclear charge increases. Shielding remains the same because total shell remains same. You know how you would be getting it after drawing the structure for sodium and chlorine. It's 17, it's 11. So this is the first shell of sodium. It's going to have two electrons, and this is the second shell of sodium. This is the second shell of sodium that is going to have eight electrons, and this is the third shell of sodium that is going to have one electron. Okay, so then I'm going to draw the structure for the chlorine as well. That would be equal to 1 2 3 4 5 6 7. If you can see, they have the same shells. I cannot say that the size would remain the same. No, because in the nucleus, proton increases. It has 11 protons. It has 17 protons. More protons, more attraction. Okay, if you can notice, they have the same inner electrons. They have the same inner electrons. It has 10 inner electrons, and also it has 10 inner electrons. So I'm not supposed to like consider. I would be only looking at that one, which would be the different. So 11 protons and one electron. 11 proton versus one electron. 17 protons versus 7 electrons. Of course, it would be having stronger attraction. That's why I am saying nuclear attraction increases. Yeah, Sayed, yes. Do you want to ask something?
No, 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 nothing, nothing, nothing.
Okay, so of course, if you are going across the period, first of all, the size decreases. The size decreases. Nuclear charge increases. Okay, nuclear charge increases. So outer electron would be strongly attracted to the nucleus. More energy would be required to remove an electron. That's why that's why the ionization energy generally increases from left to the right. Okay, generally increases from left to the right. But what is this? Why this is so? Why this is so? Why this is so? If this is lithium, if this is lithium, this is sodium, this is magnesium. Okay, or if you can say that,
Because the
uh,
energy is a bit lower.
or if you can see sodium,
Boron and oxygen.
magnesium, aluminium, silicon, phosphorus, then sulfur, then chlorine, then argon, then potassium, then calcium. So the proton number for magnesium is 12 and the proton number for aluminum is 13. Can you tell me, across the period ionization energy should increase, but what's wrong with this? Why the ionization energy of aluminium is lower than that of magnesium?
Because
So
of
first
the
of all,
2p orbital
yeah, exactly.
is
So
slightly higher
1s2,
in energy.
2s2, 2p6, 3s2, 1s2, 2s2, 2p6, 3s2, 3p one, two, no, 3p3. Okay, so 2 plus 2, 6 plus 4, 10 plus 2, 12, and then 1. So sorry, it should be 1. It should be 1. It should be 1. It should be 1. Yeah, this is the configuration. So if you're going to remove outer electron of aluminium, it would be removing from the 3p orbital, which is fifth orbital, which is 1, 2, 3, 4, 4, 5, which is the fifth orbital, which is further away from the nucleus, loosely attracted towards the nucleus. So less energy would be required to remove this electron as compared to this. 3s is fulfilled, is more stable, it's near to the nucleus, it's more attracted, more energy would be required to remove electron from the 3s orbital as compared to the 3p orbital. That's why aluminium would be having the lower ionization energy than magnesium. Remember, that's it. Are you getting my point? Yes or no? Are you getting my
Yeah,
point?
then also
Okay.
electron electron repulsion also will it be there?
Yeah, exactly. Okay. So we would be continuing like the past